Okay, so in the past couple of times, I've referred to the concepts of conventional and electron current flow, and I've just sort of vaguely glossed over them because I've been planning to do a video on them, and then I keep forgetting to do the video. So today we're going to talk very briefly, just like the Back to Basics videos are. We're not going to get too far in depth of the two concepts, but I just want to make it a little bit more clear so that when I refer to them in future videos, you'll understand what I mean by conventional and electron current flow. So this is probably the longest Back to Basics title I've ever had. So I'm just going to go ahead and erase it because I need room on my whiteboard. Goodbye text. There we go. Now it's all clean-ish. Alright, well, I shouldn't throw that over there because I'm going to still need it, so we'll put that there. So I'm just going to quickly bash out a reasonably simple circuit here. So let's we'll make a battery here, and we'll put a switch there, and we'll put a nice electrolytic capacitor here, and then current limiting resistor, and then an LED. Alright, so I'm not going to apply any sort of values to these items. I just want to sort of help visualize what the difference between conventional and electron current flow are. So in most imaginings, the way current flows through a circuit is going to be, I'm going to grab a different color here, it's going to be in this direction. The electricity flows from here, goes this way, and my pen is doing that juicy thing that it does on occasion, which is getting really annoying. Where did my new red marker go? We'll go grab that one. Alright, so it's going to be traveling around in this direction. So it'll go through the switch. Some of it will go into here and charge that capacitor until the capacitor's voltage equals the battery voltage. Then it'll go through this resistor, and then through the LED. The LED illuminates, then it goes back and returns back through the negative portion. So that's not actually how current truly flows through a circuit. Because the charge carriers in electricity are actually electrons, and we talked about those in a previous video, because they're the charge carriers, actual current flow, I'll grab a different color pen for this, is carried by the electrons, and they actually flow from negative side because they are a negatively charged particle. So in reality, what's happening is the electrons come through here, they flow up into the capacitor, again until the capacitor equals the voltage of the supply, and then they continue along, they go through the LED, through the resistor, which is going to limit the current no matter where you place it in the circuit, as long as it is in series with the current controlled devices, and then it passes through the switch and over to the positive terminal of the battery. Now, it really doesn't matter how you look at electricity flow, whether you go with conventional current flow or electron current flow. When you're looking at conventional current flow, you can also consider that the charge carriers in this case would be holes. This is a concept that I really haven't wanted to cover on the channel because I don't like electrons and holes as descriptors, but it is the accepted terminology, and I haven't really figured out a better way to describe it. But basically, let's find a new color here. Let's try orange. Let's see what the orange is like. So I'm picking orange because it's copper. So let's say we've got a copper wire, very, very heavily magnified here. And in that copper wire, we've got the crystalline structure of the copper in there. And inside that copper, you're going to have free-floating electrons. So they're just going to be kind of moving around inside the copper kind of freely. But as current begins to flow, those electrons have to move. And they move through regions that are referred to as holes. And so I really didn't plan this very well. I'm just going to erase some of my electrons here, and I'm going to make us some imaginary holes. And basically these are vacancies in the structure of the copper that can accept an electron. And so when current isn't flowing, it'll reach an equilibrium state and the holes will fill with electrons until there's a nice balance. But when current starts to flow, electrons will start to move into available holes. And of course, depending on how you look at it, either the holes are moving in this direction, which would be conventional current flow, so the holes would be going in this direction, or if you're looking at it via electron flow, the electrons are flowing in this direction. Now, why do we look at it two different ways? Well, certain circuits are easier to diagnose or troubleshoot or reverse engineer if you look at it with conventional current flow, and then others are easier to understand if you look at it with electron current flow. Now, one of the biggest questions I had that I had never really been able to properly explain to myself, and never really bothered to ask an instructor because I didn't consider it that important, but knowing that it was a question that I came up with, I figured other people would come up with it as well. And that is, when you're looking at conventional or electron current flow, how exactly does a capacitor affect the way that works? Well, if we look, remember when I talked in my Back to Basics videos about capacitors? Capacitors are basically a tank, and they fill up with electrons until such a point as the potential difference changes, and then electrons will start flowing out of the capacitor. So in this circuit, what happens with those electrons? Well, let's have a quick look at that. I'm just going to clean up my drawing a little bit here. All right, so with conventional current flow, you're going to have the holes coming along like this, and then they're going to come down and fill up this side of the capacitor, and then continue through the circuit. Well, what happens if we open this switch? Well, you still have a bunch of holes all backed up in here, which is creating a potential difference between this side of the circuit and this side of the circuit. So those holes will then flow out of the capacitor, through the resistor, through the LED, and back. Actually, they'll flow up into here. They won't flow back to the battery, to equalize that potential difference. Now, if we look at that with electron current flow, it works the exact same way. I'm totally mangling my drawing here, but we're almost done, so it doesn't matter. Let's see, I'll grab the blue one. So in this case, we've got electrons will flow through here, and then they'll fill up this side of the capacitor until the potential difference equals that of the battery, and also flow through the LED, illuminating it through the resistor, and then back to the beginning. So we open that switch, there is now a big potential difference between this side and this side of that capacitor. So those electrons are all going to come flowing out of here and back over to here. until the potential is reached. So this circuit, when you close it, the LED will illuminate, the capacitor charges up. Once the capacitor is charged, it appears as an open circuit. No more current will flow through there. So the only part of the circuit that matters then at that point is the battery, the resistor, and the LED. So we open that circuit, then this LED will fade out as the potential difference between the capacitor evens out through the circuit. And of course that works for anything from a little LED like this or a PIC. Quite often you'll see they call them a decoupling capacitor on the power input of a PIC or any other sort of microchip, and that's basically to keep the power flowing in case of fluctuation in power. You know, if this power drops, the capacitor will give a surge of current to keep the potential at what the capacitor thinks the potential should be. Anyway, I think that fairly well covered conventional and electron current flow. If I left anything out or said anything that confused you, ask questions in the comments below. If you haven't already, consider clicking here to subscribe. Right over here is a video that YouTube thinks you'll find interesting based on your watching habits. Right over here will be the Back to Basics playlist. That's the second time I've done that. And right here will be a link to Patreon. Patreon supporters do get to watch these videos a little early. So thanks so much for joining me, and we'll see you next week. Bye-bye.